Bismillahirrahmanirrahim. Assalamu alaikum. As you all know, I'm the course instructor for the course Introduction to Food Science, and today I have uploaded this lecture in the terms of the revision of your midterm syllabus. I have attached the course content in the Google Classroom forum. And if you have any queries regarding the content or regarding the syllabus or anything, you can feel free to ask. So this lecture would conclude all the course content we have done so far, and I hope you guys have developed an understanding, a basic understanding about food science till now, that how food is very important and how food is uh, performing various functions in our body and how it is related with science. What makes food more than just culinary arts but also a very important factor that is very essential in our health. So let's start with the introduction of food science as a discipline. Basically, food science is one of the human society's most important endeavors. Food is necessary, we all know, for it performs various functions like the survival, growth, physical ability, and good health. Apart from these basic functions that food performs, it is also responsible for maintaining body temperature. It gives us emotion. It provides us with the emotional needs. It fulfills our physiological needs, psychological needs, emotional needs. It is also, very important in social norms and social beliefs. It gives us a feeling of satisfaction as well as self-realization. So, food processing and handling and preparing and serving comprises the world's largest industry. Many factors require that these scientists who choose to study foods be prepared in many of the physical and life sciences. Among these are the chemistry of food, its vulnerability to spoilage, its role as a disease vector, its quality attributes, its nutritional content, and its varied sources. So, food is not simply just something that we eat to fulfill our body or to fill the satiety of that we our bellies are full and we do not we don't need anything else. It has so many other aspects, so many other things that which are, for example, that if you know the chemistry of food, if you know how to process the food and how to preserve food and what are the additives that increase the flavor or they enhance the quality of food, the color of food, it is also very important. So food science is the discipline that includes all the aspects of food like the chemistry, the bioactive nutrients, carbohydrate, proteins, fats, various vitamins, minerals in the food, and that how these nutrients could be spoiled. For example, vitamin C spoils in exposure to sunlight, and vitamin B is, as it is a water soluble vitamin, it could be lost when we when we dip rice for too much time in water and then remove that water from rice, all the vitamin B content is lost. Or during cooking practices, various nutritional losses can occur. So it deals with the vulnerability of various vitamins with the spoilage, and how food performs a therapeutic effect, how it can play its role in preventing from various diseases and to cure the diseases, and various what are the sources of food and what are the various sources of nutrients. So let us discuss the history of food science, that how it began. The origin of food science is unclear, but history reports that Egyptians, Greeks, and Romans were able to preserve a variety of foods in vinegar, brine, honey, or pitch. Drying, freezing, smoking, fermenting, and heat processing, cooking, and baking have been practiced for centuries. The first food technologists were actually discoverers, inventors, and improvers of the preservation methods mentioned previously. Later, science improved upon discovery techniques and invention, resulting in great gains to human health with the provision of a safe, nutritious, varied, and economical food supply. Some pioneers in the discipline of food science include Nicholas Appert, Frederick Acum, and Louis Pasteur. So we know that food has, been in consideration for a longer period of time, and in the past there were various techniques to preserve food, and the most common techniques were to dry food, to freeze the fish, to smoke the meat, and to ferment fruits and vegetables, and the whole purpose was to eliminate microorganisms, to delay enzymatic activity, to prevent the food from spoilage and deterioration by increasing its shelf life. So now it has emerged as a greater discipline, and it has so much significance in the industry today. In the 20th century, during the years 1895 to 38, many advances were done and in the field of food sciences and human nutrition. The role of amino acids, that are the building blocks of proteins, was explained, and how the amino acids are categorized in essential and non-essential amino acids according to their biological importance. And the various vitamins were discovered in this time period, and they named, and their functions were also determined, that what is the role of vitamin A in maintaining vision, what is the role of vitamin D in bone health, and how what are the factors that associate with the mechanism of vitamin D, and how the rickets could be prevented, and how plagiaria and goiter and beriberi can be cured and treated if vitamins are providing to the body. Canning was now a technology under scientific control, and the use of refrigeration in the storage and transport of perishable food was becoming common. Yes, it was of a great importance question, that how perishable goods could be preserved, because perishable goods are the ones that deteriorate early, that are more prone to microorganisms. They are usually high in water content, and non-perishable items are the ones that have high shelf life. They are not deteriorated. For example, in perishable food items, there could be eggs, meat, milk, poultry, and the non-perishable are, you can say, rice and grains and lentils, dry fruits. They are the non-perishable ones that have higher shelf life. Frozen foods had reached the retail level, and home refrigerators were replacing ice boxes. In that period of time, various scientists marked their name in the history, and they did a lot of effort in this discipline. Some of the names who did a lot of effort in food sciences were Samuel Prescott, William Underwood, Edwin Hart, Clarence Birdseye, and Carl Fellers. During the 1960s, advances in technology allowed for the improvement in quality of food as well. Freeze drying and the products such as freeze-dried coffee hit the market. Computer control in the processing plant was introduced, and product quality and efficiency of production resulted. Rigid and flexible plastic containers became common in the marketplace, and many new ingredients such as oil blends and flavorings was developed. And in 1970s, it was again a time for energy saving processes, and the consumption of energy dropped by 25% in most plants. By the end of the year 1970s, smaller, quicker, cheaper, user friendly computers were introduced in food plants, and thus they contributed towards the more efficient plant producing higher quality products at the faster rate. In 1980s and in 1990s, that was the time of the revolutionary period, and at industrial level, food sciences emerged as a new discipline, and the various techniques and technologies assist in spreading this discipline. Now, what is the what how food science is a discipline today? How it is taken as a discipline today? That it is representing and expected future health and safety trends. The use of sciences such as biotechnology, genetic engineering, computer technology, microbiology, and chemistry will allow the food scientists to help bring the marketplace new foods that will meet the needs and desires of the consumer. Examples of other challenges that will be faced are convenience foods, low calorie and low fat foods, quick methodologies such as gene probes or biosensors for detection of harmful microbes, inventory computerization to control and maintain quality, and computer shopping through the internet lines. All these factors will have an effect on how foods are processed, packaged, labeled, distributed, and consumed. Now we will be discussing that what are the roles of food scientists in coming years, and there are so many problems that the food scientists are facing, and there will be again so many problems they will be facing in the near future. Some problems will be new, such as the development and use of genetically engineered food sources. Others could be like the prevention of food spoilage and the poisoning of foods and the food adulteration. And these have always been with us and probably always will. In the future, we may have foods in packages with digital readouts of degrees of freshness, risk due to presence of pesticides and other compounds, and nutritional information that can be quickly analyzed by home computers to incorporate the food into specially designed diet. With all this futuristic advancement, it must be stressed that none of it would be possible without the basic in knowledge of the sciences. We must depend on the scientific method, which involves understanding the nature of the problem, the nature of the materials, and the physical and chemical laws controlling the processes. Food science is certainly one of the most exciting and potentially rewarding careers of the future, because no other person could have more knowledge to how to handle food, whether it is fruit, vegetable, or processed ones, from the time of harvesting till the time it is given to the consumers. It includes various stages like the harvesting of raw materials, then the handling of raw materials, various food processing techniques, then use of chemical additives and chemical preservatives, and then packaging, then labeling, then transportation, the considerations during transportation, and then finally to the hands of the consumer. So, food science is a very emerging discipline, and it is a very promising career as well. And now I will discuss the impact of food science on society. That it includes not only the final product, but it starts from the agriculture. Perhaps the greatest impact of food science on society has come in the area of agriculture. The earliest developments changed nomadic societies to settled ones. Once the idea of farming the same piece of land was conceived, permanent shelters became more practical ones, and the forerunners of the modern day houses were built. The protection of farms was important enough to cause farmers to group together and to establish boundaries in tiny hamlets, the forerunners of the modern day towns and cities. As agriculture improved, farmers became more efficient, and fewer farmers were able to supply food for more and more people. This freed a large portion of the population to engage in other efforts such as manufacturing, construction, transportation, education, research, and medical services. So, uh, we can conclude that food science spared many of the other fields, and it gave so much manpower to other sciences, to other things as well, regardless of just the farming and the agricultural conventional methods. Now we will discuss food science as a profession. It is one of the most important because it is the device by which we can control the availability, the nutrition, and the wholesomeness of the food, of the commodity that is critical to human survival. It is timely because we are in the era of significant technological advances, and with these advances come a need for an understanding of the way of our food is grown, it is harvested, transported from one place to another place, then it is stored, and then again it is processed and packaged, inspected, then it is distributed among the whole retailers, and then it is advertised, then marketed, and then it is sold, displayed, prepared, and then served. So it is a long chain of events that a food scientist should be well aware of. Food safety is the top priority in all the stages, and from the handling of the raw materials, and then the serving of the end product. And it is the top priority of the food distribution chain, and the food science and its understanding is becoming increasingly necessary in all steps of food processing and distribution. Its relevance to other disciplines is apparent, and colleges and universities offer special practical courses in food sciences as science electives to non-science majors as well. Now, constituents of food and the properties and their significance. As we know, a meal, what we eat, for example, if we eat a burger, it is not just a single uh, nutrient. It has a bunch of nutrients, and a food is something that provides us with a lot of nutrients that could be categorized into macronutrients and micronutrients. Macronutrients are the ones that are required in greater quantities like carbohydrates, proteins, and lipids, and the micronutrients are the ones that are required in less quantities like vitamins and minerals. Each and every nutrient has specific purpose to perform. They have different metabolic rate. They have different metabolism mechanisms. Their mode of absorption or the mode of action varies. So food is a complex mixture of chemicals that an organism takes in and then assimilates to promote growth, to expend energy, to replace worn or injured tissues, and to prevent some diseases. The main nutrients are the proteins, carbohydrates, and lipids, which are organic in nature. And with they are not provided solely. Water is important part of their structure, and usually water makes more than up to 97% of the total food's mass. The remainder consists of thousands and more compounds, which exist in small amounts, measuring in the concentrations of ppm or less. These compounds are mainly responsible for the taste of the food, the odor of the food, the appearance of the food, and color of the food. Vitamins and minerals also exist in minute amounts and are extremely important in many of the body functions. Most food constituents contain chemically active groups that can enter into complicated series of reactions with each other or with surrounding materials such as air, water, packaging, and equipment. Heat, moisture, and concentration changes in food processing together with biological catalysts called enzymes also may induce reactions. The resulting changes in the food may be desirable or undesirable, and the food scientist must be able to predict and control the changes to gain the desired effects. So, this is the food pyramid that is being proposed by USDA, and after putting a lot of effort in it, and finally, this could give us a preview that what we should eat, how much, which food sources should be the core, should give the baseline, and what should be used sparingly. So, as we can see here, the orange portion, the pedestal of this pyramid, it gives the highest percentage of the total caloric intake, that is around 40%, and it includes bread, pasta, and cereals. All the cereals like wheat, barley, rice, rye, oats are in this baseline, and these are the basic whole grains and whole foods which are carbohydrates in nature. Above it, we should get 35% of our calories from fruits and vegetables. Fruits and vegetables are enriched with very bioactive components like polyphenols, flavonoids, antioxidants, which have anti-inflammatory, anti-proliferative characteristics. And fruits and vegetables play a significant role in anti-inflammation of the body. They can, they have so many roles in preventing from diabetes, from obesity, from hypertension, from cardiovascular diseases, from weight gain, and from aging as well. They keep your body hydrated, and they are also very important in the normal bowel functioning because they are enriched with fiber, which has no caloric value but so many other important functions to perform. Above it, in the violet area, we can see that this is the group of the meat, fish, milk, and eggs. Now, we can have 20% of our total caloric intake from this group, and the meat, fish, and milk and eggs are this is the protein group. Uh, Milk has the saturated fat content as well, but mainly it is the protein group. Again, we have to be very careful about the source of the meat, that whether it is the red meat or the lean meat. Lean meat is more preferable as it has lower levels of cholesterol, and it cannot be, assist in developing certain cardiovascular diseases. On the top of the pyramid, there are the things that we have to take in minute quantities, or we should use sparingly, and these are the fats and oils and the sugars and the sweets. These are the ones that have the negative effects on our body health. And as we know that sugars are the refined products, these are just the empty calories, that they are not providing our body with any healthy nutrients, but just they're adding up to the calories of what we are eating. So next, the first the macronutrient we will be discussing are the carbohydrates. Carbohydrates, as we know, are the polyhydroxyaldehydes or polyhydroxyketones. Poly means many, hydroxy means hydroxy group, functional group. Carbohydrate, as the name suggests, composed of carbon, hydrogen, and oxygen, and in which the ratio of hydrogen and oxygen is same as that is in the water, that is two atoms of hydrogen and one atom of oxygen. There could be other small quantities of other compounds, other elements like sulfur and other minute minerals. The prime function of carbohydrates is to give energy, is to provide energy to our body, and that energy is utilized in the daily functioning of life, whether they are the voluntary actions or the involuntary actions. Carbohydrates are the ones, they are the prime source of energy. So, to carry out its day to day physiological functions and maintain a constant body temperature, the body requires a constant source of energy. Beyond its continuing maintenance need for energy, the body periodically needs relatively larger amounts of energy to do work or to engage in other vigorous physical activities. Humans derive their energy mainly from the carbohydrates, around the 55 to 65% of the total caloric intake, although they can also utilize fats and proteins for this purpose. Yes, there are also, if your body, you are not having proper carbohydrates, your body can generate energy from other sources rather than carbohydrate, that is lipids and proteins, through a process known as gluconeogenesis. And the carbohydrates are a class of compounds that consist of carbon, oxygen, and hydrogen. The carbohydrates that are important in nutrition include sugars, starches, dextrins, and glycogen. Others that are not digestible, they are fibers, they do not supply calories but are very important in the overall health and well being of the human body. Now I will discuss monosaccharides. Now I'm going to discuss the classification of carbohydrates. Carbohydrates are mainly divided into three categories: monosaccharides, oligosaccharides, and polysaccharides. Monosaccharides are the ones, mono means simple and saccharides means sugars. They could be aldoses or ketoses depending upon whether they are containing the aldehyde functional group or the ketonic group. They usually have 3 to 9 carbon atoms in their structure, and monosaccharides are the simplest sugars. They cannot be hydrolyzed because they're already in the simplest form. The most common monosaccharides are either the pentoses or hexoses, that where they contain five carbon atoms or six carbon atoms. Each carbon atom carry a hydroxyl group with the exception of the atom that forms the carbonyl group, which is also known as the reducing group. Simple sugars are specially active compounds and can contain several asymmetrical carbon atoms. This leads to the possibility for the formation of multiple stereo isomers or enantiomers of the same basic structure. To simplify matters, monosaccharides are assigned optical configurations with respect to the comparison of their highest number asymmetric carbon atom to the configuration of D-glyceraldehyde or L-glyceraldehyde. The next classification of carbohydrate is disaccharide. Basically, disaccharide comes under the category of oligosaccharides that yield about 2 to 9 units of monosaccharides upon hydrolysis. Disaccharides, as the name suggests, di means two and saccharide means sugar. These are the sugars that upon hydrolysis yield 2 units of monosaccharide. And disaccharides are formed by the condensation of the two monosaccharide units from a glycosidic bond. A glycosidic bond is that between the hematical group of saccharide and the hydroxyl group of another compound which may or may not be itself a saccharide. Disaccharides can be homogeneous or heterogeneous and can be categorized as non-reducing sugars or reducing sugars. Non-reducing sugars are the ones in which the monosaccharide units are joined together by a glycosidic bond formed between the reducing groups, that is, for example, sucrose and trehalose. This inhibits further bonding to other saccharide units. And the other classification is reducing sugars, in which the glycosidic bond link the reducing group of one monosaccharide unit to the non-reducing alcoholic hydroxy of the second monosaccharide unit. A reducing sugar is any sugar that in basic solution forms an aldehyde or ketone, allowing it to act as reducing agent and therefore includes all monosaccharides. Uh, Common disaccharides can include the sucrose, lactose, maltose, galactose, and galactose, nahi. Sucrose, lactose, and maltose. These are the most common ones. Common monosaccharides may include glucose, fructose, galactose, and mannose. First we will be discussing sucrose. It is the substance that we commonly termed as table sugar, and in our households it is there as sugar, and it is found in many plant foods and saps. It is isolated commercially from sugar cane or the roots of sugar beet. Now, sucrose is composed of D-glucose residue linked to alpha D-fructose residue, and it is a non-reducing sugar. The other one is lactose. Lactose yields two units, 1 unit of glucose and 1 unit of galactose. Lactose is the only source of carbohydrate that is from animal source. It is not found in any plant or cereals. It is the only source of carbohydrate that is from animal origin because it is found in mammalian milk. To aid in the digestion of lactose, the intestinal villi of infant mammals secrete an enzyme called lactase, which cleaves the molecule into two subunits. In most mammals, the production of lactase gradually reduces with maturity into adulthood, leading to the inability to digest lactose and so-called lactose intolerance. Yes, it is a condition in which your body is unable to digest the dairy products, because in milk there is lactose, and as your body deficient in lactase, the enzyme that acts on lactose, it diminishes, and thus the person becomes lactose intolerant. The third common disaccharide we will be discussing here is maltose, that yields 2 units of glucose upon hydrolysis. Maltose is formed by the enzymatic hydrolysis of starch, and it is an important component of barley malt, which is used in brewing beer. It is a homogeneous disaccharide consisting of 2 units of glucose. The next are the polysaccharides, and they contain up to thousands and thousands of monosaccharides, and these are the most complex carbohydrates. Poly means many, and sugar saccharides means sugar. So these are the built of repeated units of monosaccharides and are systematically named with the suffix n. The generic name of polysaccharides is glycan, and these can be homoglycan consisting of the one type of monosaccharides or heteroglycans consisting of two or more than two types of monosaccharides. Polysaccharides have three main functions in both animal and in plants: as source of energy, as structural components of cells, and as the water binders. Plant and animal cells store energy in the form of glucans, which are polymers of glucose such as starch and glycogen. The most abundant structural polysaccharide is cellulose, which is also a glucan and is found in plants. Water binding substances in plants include agar-agar, pectin, and alginate. Polysaccharides occur as several structural types, that is linear. They could include amylose and cellulose, the branched ones that are the amylopectin and glycogen, the interrupted, for example, pectin, the blocked ones, for example, alginate, or the alternate repeat, for example, agar and carrageenan. So now some of the important polysaccharides are discussed in this slide, and the first one is starch. Starch occurs in the form of semi-crystalline granules ranging in size from 2 to 100 micrometers and consists of two types of glucan, that is amylose and amylopectin. They have two types of polysaccharide in their chain. Amylose is the linear polymer, that is the linear square chain, whereas amylopectin is randomly branched and it makes various linkages of glucose units and also being involved in 1 to 6 link branches. On average, the length of linear chain in amylopectin is about 20 to 25 units. Starch granules undergo a process that is called gelatinization. If heated above their gelatinization temperature, 55 to 70% degree, depending on the starch source in the presence of water. Prolonged storage of a starch gel leads to the onset of a process termed as retrogradation, during which the amylose molecules associate together to form crystalline aggregates, and starch cells gels undergo shrinkage and syneresis. The next polysaccharide I will be discussing is glycogen. The polysaccharide that animals use for the short-term storage of food energy in the liver and the muscles is known as glycogen. Again, glycogen comes in the minute amount from the sources, but it is the stored form of carbohydrate in our body. If the intake of carbohydrate excess from our energy expenditure, our body stores excessive carbohydrate, excessive glucose in the form of glycogen. Glycogen is similar in structure to amylopectin, but it has much higher molecular weight and a higher degree of branching. The next one is cellulose, that is non-digestible part. It is the structural part of plants, and cellulose is a linear polymer like glucopyranose residues. The linkage in cellulose is not susceptible to attack by slurry amylases that break down starch linkages, and therefore it is non-digestible, and it is termed as a major part of dietary fiber. The other ones are the pectins, that are the gel forming agents in carbohydrates. Pectins are heteroglycans and have complex structures. Pectins are characterized by smooth regions that are free of L-ramanose residues and hairy regions consisting of these two residues. Gums have a high affinity of water and have a high viscosity aqueous solutions, but are not able to form gels. The reason for this is that all gums possess structures that incorporate a very high degree of branching or highly interrupted chains. This prevents the formation of junction zones that were present in the case of pectins, that are a feature of polysaccharide gels. A notable gum that is commonly employed in foods is xanthan gum. So now I will discuss the processing method of carbohydrates in food industry, and the first one is caramelization. It is when it occurs when a concentrated solution of sugars is heated to temperature more than the boiling point of water, that is 100 degrees Celsius. Various thermal decomposition reaction occurs that may change the structural integrity of sugars, and they may change the flavor of the starch as well, and the brown colored product appear. This process, which particularly occurs during the melting of sugars, is called caramelization, and it is a non-enzymic browning reaction. The other processing that occurs in carbohydrate processing is Maillard reaction. Maillard reaction is the chemical reaction between an amino acid and a reducing sugar. That the formation of a pool of reactive intermediates lead to the formation of flavor compounds and pigments. Now I will be discussing about proteins. Proteins are the main nutrients. These are the macronutrients that aids in the cell growth, repair, and cell maintenance. Your body is made up of flesh, that is mainly protein. What makes protein different from carbohydrate and lipids is the presence of nitrogen. They are also organic compounds composed of carbon, hydrogen, and oxygen, but the content of nitrogen makes them different from other nutrients. So these are the chief organic constituents of muscle and other tissues. Proteins are major components of the enzymes that regulate and carry out the general metabolism and functional processes of living organisms. Proteins are part of the intracellular and extracellular structures of animals. They make up the structure of many hormones and antibodies and are concerned with many other factors involved with the body functions. Proteins contain nitrogen, carbon, hydrogen, oxygen, and sometimes sulfur and phosphorus. Most proteins contain nitrogen at the level near 16% of their total composition. Proteins are very complex nutrients that are made up of amino acids. Amino acids are the building blocks of proteins that consist of an amino group and a carboxyl group. That you can say that they have both the acidic side and the basic side at the same time. Amino acid in solution at neutral pH are predominantly zwitterions. The ionization state varies with pH. At acidic pH, the carboxyl group is unionized and the amino group is ionized. At alkaline pH, the carboxyl group is ionized and the amino group is unionized. Biologically important, if we talk about the biologically important amino acid, there are 20 amino acids that are very significant, and out of them there are 11 non-essential and 9 essential amino acids. Why they are termed as essential and non-essential? Because essential amino acids are the ones your body cannot synthesize on their own. They must be provided by your diet, and they form the complete protein. The non-essential amino acids are the ones your body can synthesize from the essential amino acids. And they are usually from the plant sources, whereas essential amino acids are usually from animal sources. The properties of proteins I will be discussing here are solubility and water binding. Solubility, there's a difference of this property among proteins. The difference occur due to the nature of amino acid content present in them and the sequence of amino acid and the structural integrity of the proteins. Some proteins like histones, which are involved in protein replication, and albumin, such as oval albumin in egg, white and lactoalbumin in milk, and albumins of blood, are soluble in pure water, but some proteins, that is, they are found in the nails and the hair, are insoluble in water. Proteins such as those in the muscle tissue of meats are able to bind water molecules through forces such as hydrogen bonding. This is great advantage when making ground comminuted products such as hot dogs and bolonga. An emulsion is made with the fat, protein, and water, and when the product is cooked it will retain much of the moisture and a palatable attractive product is obtained. Now I will be discussing the structure of protein. Protein structure is really very complex, and it has various phases. That there are simple proteins and the complex proteins. They are made up of the primary structure, then the secondary structure, then tertiary structure, and then the quaternary structure. Properties of protein also include the denaturation, that if you cook protein for for a longer period of time at high temperature, the protein denatures. The conformation or the secondary, tertiary, and quaternary structures can be quite fragile and may be altered by a number of factors that may be utilized in food processing. This change in molecular structure without breaking covalent bonds or altering amino acid sequence is referred to as denaturation. With denaturation usually comes the loss of biological activity and significant changes in some physical or functional properties such as solubility. Denaturation occurs only in proteins and protein like substances that have different levels of effect on individual proteins. Reduction is also an important property of protein, in which there are various subgroups in a protein molecule that are susceptible to oxidation, and the formation of disulfide bonds form between two sulfhydryl groups of the same molecule or the different molecules that may increase in the rigidity of the protein texture. Hydrolysis is where at the hydrolysis in proteins is the cleaving of the peptide bonds by addition of water molecules. This can be used by strong acids, alkalis, and certain enzymes. Hydrolysis may be complete or partial. Now, I would like to talk about lipids. These are the macronutrients that provide the maximum energy. 1 gram of lipid give you about the 9 kilocalories. So these are the heterogeneous groups of substances that are associated with living systems, and they have mainly the property of insolubility in water, but solubility in the non-polar solvents such as hydrocarbons or alcohols, etc. The major member of this group are the fats and oils, which are given the most emphasis in this section. Other members of the lipid groups include waxes, phospholipids, sphingolipids, and sterols, which all have various important roles in food and biochemistry. But nutritionally, the fats and oils contain 9 calories per gram, while proteins and carbohydrates contain only 4 calories per gram. Lipids could be classified as the simple lipids, the complex lipids, or the derived lipids. Simple lipids yield two classes of product when hydrolyzed, that is glycerides, and when which are hydrolyzed to give glycerol and a fatty acid. Complex are the ones which, after hydrolysis, yield various products such as phospholipids, which are hydrolyzed to give alcohols, fatty acid, and phosphoric acid. Derived ones are the ones that are non-hydrolyzable and do not fit into either of the above classes. You can say like the vitamin A, tocopherol, and sterols. Now, fats and oils. Fats are the ones that are found as solid at room temperature, and the oils are the ones that are liquid at room temperature. Both of these are made up of fatty acids that could be saturated fatty acids or unsaturated fatty acids. If there are saturated fatty acids, they constitute fats, and if the unsaturated fatty acids are there, they constitute oils. The sources of fats usually come from animal origin, like plants, like animals such as lard and soot and milk. We make ghee and margarine and the banaspati ghee from milk. And oils come from plants, that is sunflower oil, coconut oil, palm oil, olive oil. As far as health is concerned, we should limit the intake of saturated fat up to 7% of our total caloric intake, because they can lead to various health disorders, commonly targeting heart and vascular diseases. So fats and oils are glycerol esters of the fatty acid, and the fatty acid esterify themselves with glycerol molecules and forming triglycerides. And fats and oils as carbohydrate contains carbon, hydrogen, and oxygen. Fats may occur in foods as lipid materials that are solid at room temperature, or as oils that are liquid at room temperature. The reason for the variation in the melting in points of these is the fatty acid components in the molecule. Fatty acids are the aliphatic carboxylic acids. Natural fatty acids, mostly commonly found in fats and oils, almost contain an even number of carbon atoms ranging from 4 to 28. Fatty acid could be saturated or unsaturated. Those who have the maximum number of hydrogen atoms and the valency of carbon is fulfilled are termed as saturated, whereas they are lacking hydrogen at certain points are termed as unsaturated. Unsaturated fatty acids occur in both plants and animal sources, but mostly they are prevalent in the oils such as corn oil, sunflower oil, canola oil, olive oil, whereas fatty acids with one double bond are monounsaturated and they are most heart friendly. For example, olive oil with two or more double bonds are known as polyunsaturated. They are found in fish, and they are also good sources of omega 3 and omega 6. The various processing techniques of fats and oils include hydrogenation and interestrification. Hydrogenation is an important industrial process to convert liquid oils into semi solid fats for the production of margarines or shortenings. For example, in mayonnaise, we can see the this is the hydrogenated oil that convert oil into semi solid margarine. Interestrification is used to improve the physical consistency of fat, and it is possible to perform interestrification, which rearranges the fatty acids so that they become distributed randomly among the triglyceride molecules. Lipid oxidation is the major cause of food spoilage and causes the generation of off flavors and off odors that are termed as rancid. The fundamental mechanism of lipid oxidation is that of autooxidation, which comprises three steps of initiation, propagation, and termination. The initiation step involves the generation of highly reactive free radicals. These then react with atmospheric oxygen to generate peroxy radicals, and the chain reaction is set in motion until terminated by the formation of non radical products. To prevent this oxidation, antioxidants are very much important. They scavenge these free radicals and thus uh, protect our body from various inflammatory reactions. As I've told you earlier, that 1 gram of carbohydrate yields 4 kilocalories, 1 gram of protein yield about 4 kilocalories, but fats and oils provide as double as carbs and proteins by providing 9 kilocalories per unit. So there is a difference between energy density and nutrient density. The energy density is defined as the energy content per gram of food. The high fat and low moisture content of most Western foods makes energy density an important contributor to energy regulation and overweight. Whilst the addition of fat and sugar increases palatability and taste, they both contribute to energy density of foods. In many developing countries where the staples are cereal based or tubers, the energy density on cooking is very low. This is largely due to the considerable absorption of water during gelatinization of starch. Now, heat treatment of foods afford the following advantages and disadvantages. It may activate or inactivate various microorganisms. It can activate or denature anti-nutritional factors. It could enhance the development of flavors and colors. It produce flavor volatiles. It may denature protein, gelatinize starch. It could destroy various vitamins and enhance the rancidity of oil. So I would like to conclude my presentation here, uh, hoping in mind that you guys will be able to prepare and get knowledge from this lecture as well. And I would like to say best of luck for your midterm examination. If you have any queries regarding this lecture, you can ask in the comment section.